Okay, let's look at scientific notation. Multiplication and division, the first two problems, do not care if the exponents are the same. So we can just right off the bat start doing the work. So in this one we have 4 times 5. So 4 times 5 would be 20. And then we're going to multiply 10 to what power? Well, we know when we multiply, we add the exponents. So we would have 20 times 10 to the 8th. However, we cannot leave it like this because, as we know, scientific notation has a number always that's between 1 and 10. 20 is too big, so we have to change it. We've got to make it into a smaller number. So in this case, we're going to take that decimal right now that's at the end of 20, and we're going to take one step back. So it's going to become 2, which means we need to take the exponent and make it one step forward. So we're going to have 2 times 10 to the 9th power. We do the same thing over here, except this time it's division. So we're going to divide 4 divided by 5. Well, if you're not sure what 4 divided by 5 is, you can set up a division house if you want to, or you could also do it as a fraction. Guys, every single time we divide, the first number always makes it inside the house and he locks the door. The last number gets stuck outside. So if you had the 5 on the inside and the 4 on the outside, you have done it incorrectly. And it should have, raised some red flags to you because obviously 4 divided by 5 is going to be a number that's smaller than 1 because 5 doesn't go into 4. 5 is too big, right? So you should have gotten a decimal with this one, and the decimal would have been 0.8. So we've divided and we do 0.8 times, and then this time, since it's division, we're going to subtract our exponents. 7 minus 3 is 4. Now, we can't leave it like this because this is not in scientific notation. This number has to be between 1 and 10. So this time, we're going to take this decimal and take one step forward. We're making this number bigger, which means we need to take this exponent and take one step back. So it becomes smaller, and I'm going to let you do that one. For these last two problems, addition and subtraction are the snobby operations, right? They say you have to look exactly like me in order for me to combine with you. So we have to take, in this case, the 10 to the third, and we need to make it 10 to the fifth. Okay, and so in order to do that, we're obviously taking 2 steps forward. We are making this exponent bigger by 2 steps, which means we need to make this number smaller by 2 steps. That's 1 step, that's 2 steps. And so this is actually 0.04. So 0.04 times 10 to the fifth, and then we're adding 5 times 10 to the fifth. And so we're still going to wind up with something times 10 to the fifth because remember, when we are adding and subtracting, exponents don't change. The question is, what is that number? Well, we have 5 and we're adding 0.04. So that's going to go here. This last one was actually the most straightforward of all of them because check it out. This is 10 to the sixth, and this is also 10 to the sixth. There was nothing that we had to do ahead of time. We know we're still going to have something times 10 to the sixth. Just like we had this times 10 to the fifth, remember our exponents never change when we're adding or subtracting. So we're going to have something times 10 to the sixth. What is that something? 5 minus 3. And that would be your answer here.